Alright guys, we're going to do section 10.9, systems of inequalities. And pretty much when you're doing a system of inequalities, all the rules for graphing a single one still hold true. So think about something like an Algebra 1 example here. Y less than 2x minus 1. So we're going to graph that. We all know how to graph a line, hopefully by now. We're going to go -1, y-intercept. So then from y-intercept -1, we're going to go up to right 1 for slope. So up to right 1. We do have to remember, because there's no equal to in this, it's just a less than. We're going to do a dotted line. And then it's less than, so I'm going to shade below the line. Okay, so all these systems of inequalities, they're all going to have some kind of shading on them. Alright, so now let's take a look at one that's maybe a little more difficult. Take a look at this first example. You do have to recognize your shapes here, because chances are I'm going to make you do these without a calculator. So if I look at this first one, x squared plus y squared less than 9. You do have to remember that's going to be a circle. Alright, and if this 9 is r squared, the radius should be 3. So center of the circle 0, 0. Radius of 3. So I'm going to go 3 in each direction. Okay. This circle will be dotted again, so when I graph this in, make sure you give it a dotted circle. Okay. And if the inequality says all the circles with radius less than 3, it makes sense we should shade inside the circle. Okay, so that's the circle part of things. Then the next one we have to recognize that's going to be a parabola. So vertex at 0, 0. And for this one, our general points are 1, 1, -1, 1. And this one's going to be a solid parabola. Alright, now the shading for this one might not be as easy to spot. You guys will get pretty used to doing it. But if you remember from Algebra 1, if we're not sure which way to shade, what we do is we pick a test point. Now, you can pick any point you want, as long as it's not on the parabola. So for instance, I'd love to be able to pick 0, 0, but that's right on the parabola. So I'm not going to pick that one. I'm going to pick 0, 1 this time. Okay, so 0, 1 is the point right here. And then I'm going to plug it into the parabola inequality. So 1 where the y is, 1 greater than or equal to, 0 where the x is. Then you have to ask yourself if that's true or false. So 1 greater than or equal to 0, that's true. So if the statement is true, you're going to shade where the test point occurred. So inside the parabola rather than outside. Now, when you're graphing these, so let's just pretend this is a quiz question, make sure you go back over, because probably you're not going to have two different colors, and really darken in where the two shadings overlap. Okay, so the solution to that would be that kind of really dark blue shaded area there. Alright, let's take another look at example number 2 here. Alright, so you could have 2, 3, 4 inequalities, however many I want to give you, and when you have a bunch of them, just try to be as exact as you possibly can, because when the shadings start going a little crazy, it might get messy. Alright, so the first thing we have here, we have a cubic function, so we have to remember how to graph that. We have a line. Then we have another line, so let me just do a little bit of work. Let's get y by itself. Alright, let's graph these three functions. Okay, cubic functions, here we go. This one goes through 0, 0. Haven't shifted this one. Some of them will be shifted, so keep your eyes on that. Alright, regular old cubic function. Here's what it looks like. Alright, solid cubic, not a dotted one here. Alright, now again, the cubic function might be a little bit tough to recognize where to shade. So I'm going to pick a test point. Okay, once again, 0, 0 I cannot choose. So my test point is going to be 0, 1 again. And when I plug it in, 1 for y, 0 for x, I get another true statement. So if 0, 1 is right here, and it's true, I'm going to be shading to the left, kind of above this cubic function. Okay, alright, let's do the next one. Next one's a line, not too crazy. Y-intercept of 4, 1, 2, 3, 4. Slope of up 2 over 1. Alright, this one's going to be another solid line. And keep in mind, quizzes and tests, I'll most likely give you graph paper so it won't be so messy like this is. And this one is a y less than the line. So I'm going to start being a little more careful how I shade now. It's below the blue, but above the red, so there's kind of the overlap part. And then if I do one more, alright, y greater than -x, okay, y-intercept, 0, 0, down 1, right 1 for slope. This time make sure you give it a dotted line. and it's y greater than, so above this, but still wherever the blue and the red are overlapping. All right, so this kind of crazy yellow mess in here, if this were a quiz, that would be my final answer. Okay, so the last part of section 10.9 is a word problem or word problems, linear programming examples. And, you know, what would a section be without some word problems? Now, this is pretty important stuff because you guys are going to be doing a project on this. So there'll be some easy questions, some hard questions. And so this I would call probably an easy type of question we're going to go over so you get the hang of them. And then you guys are going to do some harder ones for your project. Okay, so here's what I want you to do. Hit the pause button for me after you kind of read the question. And I want you guys to figure out what should I let x equal and what should I let y equal. So hit the pause, read the question, and then see what you can do. All right, so I'm assuming you hit pause. Now we're back. So here's what I think. I think we should let type 1, or the amount of type 1 food, equal x, and the amount of type 2 food, we're going to say equals y. Okay, so we need to set up 3 inequalities here. As well as the inequalities, we need to set up a cost equation. Because if you read the question pretty carefully, we want to hit all the requirements at a minimum cost. So for all of these linear programming problems, we're either going to be maximizing something or minimizing something. Usually we want to maximize profit, we want to minimize cost, just a basic business model. So for this one, we're minimizing cost. So I can already kind of come out to the side here and write a cost equation. My cost equation is going to be from the amount per type. So 20 cents per type 1, 30 cents per ounce of type 2. So I would say something like this. It's going to be 0.20 x plus 0.30 y. That's my cost equation. You always want to have a cost or a profit or something that you need to minimize or maximize. All right, now I'm going to come up with 3 inequalities. The 3 inequalities are going to be represented by the types of things in each food. The first one's going to be a fat equation, or inequality, not equation. So if I'm looking at what I have type 1 with 8 grams of fat, type 2 has 12 grams of fat, and I need a min of 24 grams of fat. So here's what it would look like. 8 from type 1 plus 12 from type 2. And it says a minimum, so that implies greater than or equal to 24. Okay. Now, if I do the same thing for all the other parts of it, so the next one would be a carbohydrate. So 12 carbohydrates, 12 carbohydrates. Minimum of 36 carbs. Okay, so here would be my next one. So it's going to be 12x plus 12y greater than or equal to 36. Okay, all right, let's do one more. I think you're kind of probably getting the hang of it. So the protein one then is going to be 2x's plus 1y greater than or equal to 4. Okay, now here's how we solve these. We need to graph all 3 inequalities on the same axis. And when I do that, they're all going to be shaded because they're all inequalities, so it's going to be above for all of them. And then what I have to find out, let me see if I can get some more space here. I need to find out on my XY axis grid, where do these 3 lines meet and at which of these points is going to give me a minimum cost. Okay, so I do have to do a little bit of work. And I know you guys can all handle this. So we have to get y by itself in each of these equations. Here's the first one. All right, so get y by itself. Here's what I get. All right, here's the next one. Y by itself. Oops, not equal, sorry. Greater than, messy. That should, all right, hang on. Let's do that again. That was really messy. All right, greater than or equal to. Greater than or equal to, there we go. Negative x plus 3. And again, all I'm doing is I'm getting each of these with y by itself, so they're all set to graph. Okay, now, whoops, that was supposed to be 4 there. What would it be without a mistake? Okay, there we go. Now, if you graph all 3 of these, it's going to be a bit messy, but I'm going to do my best and really try, if you had graph paper in front of you, that would be the best thing to do. I'm going to do my best here. Okay, so the first one, up to 2, down to right 3. Here we go. And all these are going to be solid. Okay, there's the first one. And I'm going to just very lightly shade because it's going to get kind of messy pretty quickly. All right, let me grab another color here. All right, let's do the next one. Y-intercept of 3 this time. Down 1 over 1, down 1 over 1. And again, I'm going to try to be as exact as possible because I can already tell I'm not doing a very good job of being nice and neat here. All right, so yellow and black, that's where they overlap. Okay. And I should have said this earlier, but with all these linear programming, cost equations, profit equations, we want to stick with most of the numbers in the first quadrant. We want positive bunny rabbits, positive numbers of kids in classrooms, those kind of things. Okay, so here's 4, down to right 1, maybe do one more time, right 1. All right, here's the blue guy in here. Okay, now if I go above the blue, or to the right of it if you want to think about it like that, but then only where yellow and black overlap, and also stay in the first quadrant. All right, here's my mess. Hopefully, like I said, you guys are staying as neat as humanly possible with this crazy mess here. All right, so here's what I've got now. Let me see if I can get a crazy color. Let's see if white will show up on here. We've got 3 corner points of this blue mess. Okay, here's the first corner point right here. That point, since it's the y-intercept, is kind of easy to see. That's going to be 0, 4. Okay. If I look at the next corner point, so where the yellow and the blue lines meet, that point is going to be 1, 2. Okay. And if I do one more like that, the other point of this blue shaded region is going to be the point 3, 0. Okay. So remember those 3 points. I'm going to move my screen up a little bit so we can see that cost equation again. All right, so take a look at the cost equation I have up there now. It's 0.2x plus 0.3y equals a cost. So the 3 points we're going to choose are those 3 corner points. And we're going to plug each one in and see what the resulting cost is. So if I plug in the 0.04 for x and y in the cost equation, I get $1.20. And check that out if you're not quite sure. I'm going to take the 0.12, plug it in, I get 80 cents. Okay, then I take the 0.30, plug it in, I get 60 cents. And then you just have to take a look back at the original question. What am I trying to do? I'm trying to minimize the cost. So I want the smallest amount of cost. So what that means is I want 3 ounces, so here's the big winner of the problem here, 3 ounces of type 1, type 1, and 0 ounces of type 2. Okay, so there's my crazy answer to the final problem.